Hi everyone, this is Mrs. Musoff here. Today we are going to talk about solving and graphing linear inequalities. Alright, the nice thing about solving inequalities is it's really similar to solving an equation. In fact, it's almost identical. There's just one extra rule that we have to follow. We're going to talk about that later. When we say graphing linear inequalities, we're just going to graph those on a number line. And the reason for that is because you'll see we only have one variable, which means it's one dimension, and we use a number line when we're talking about one dimension. Okay, I know sometimes we have trouble remembering what each of the inequality symbols means, so this right here is a nice little summary to help you out, so you can always look back at this if you need a reminder. Okay, the trick that I use is, since we read left to right, when you see a symbol that on the left side is the bigger opening, that's going to be greater than. Whereas when you see on the left side the symbol with the smaller piece, that's going to be less than. Okay, once you've got that down, the only extra thing to figure out is whether there is a line underneath or no line underneath. That line means equal to, which means whatever number you're talking about, you're allowed to have that number as your solution. And the big thing with that is when you see that line, like in these two symbols, like I said, it means equal to. That means when we graph it, we're going to use closed circles. Okay, so you can see an example right below. For example, if we ever have x is less than -2, that means all the numbers, x represents the numbers, our solutions, right? So our solutions have to be less than -2. Since there's no equal to, we don't include 2. It cannot equal to. And that's why right here, we have an open dot, an open circle. Alright, then I shade towards the numbers that are smaller than -2. Smaller than should be to the left, bigger than should be to the right. Okay, so let's test this out. Let's try graphing a few. Number 1, it says x is greater than -5. So the first thing I'm going to do is draw, maybe a straighter line for my number line. There we go. And I'm going to plot -5 down. Okay, now one thing we like to do is have a few numbers on each side just to make sure we know which side's smaller and which side's bigger. So to the left side we should get more negatives, so like -6, -7. And on the right side we should get less negatives, so -4, -3. Okay, so the first thing we're going to check is whether we need an open or closed circle. So the first thing, open or closed. And again, the way we can figure out this piece is by looking at the symbol. If there's no line underneath, then we're going to go with open. If there is a line underneath, then we would go with closed. Alright, so I'm going to put an open circle at -5. And then since the left side of this is the bigger piece, that's going to be greater than -5. So this is x is greater than -5, if you want to write it down to help you out. So greater than should always be shaded to the right side because that's where numbers get bigger if we move to the right. So to shade that, I'm just going to draw some shaded lines. And then we can't do this forever, right? So at some point we just have to kind of finish it off with an arrow. And this graph represents all the numbers that are greater than 5. Open circle means not -5, but everything bigger. Okay, same thing with number 2. This says x is greater than, because the bigger side is to the left, or equal to, because it has the line underneath. Alright, so greater than or equal to 4. So when I draw this number line, I'm going to plot 4, and then a few numbers bigger, and a few numbers smaller. Now since it's equal to, that means closed circle. So I'm going to put a closed circle at 4. And once again, greater than or equal to. Greater than we shade to the right because that's where our bigger numbers are. So shade to the right, draw my arrow, and there we have it. So any number that's part of the shaded region should be answers. Right? Like 5 is in the shaded region, and 5 is greater than or equal to 4. So that makes sense. Alright, couple more. X is less than, smaller side, so less than -3. So again, I'm going to draw my number line. I'm going to plot negative 3. To the left should be more negative numbers, negative 4, negative 5. To the right should be less negative numbers, so negative 2, negative 1. Alright, this is strictly less than. There's no line underneath. That means it's an open circle at negative 3. And then less than, think less than to the left. So when it's less than, we're going to be shading to the left. Boom, boom, boom. Alright, so again, any number that's in that shaded region would be a solution to this inequality. Okay, last one. X is less than or equal to, less than because it's the smaller end, and then the line is equal to 7. So again, draw that line out, plot 7, a few numbers bigger, a few numbers smaller. Since it's equal to, we're going to put a closed dot at 7, and then less than is to the left, so I'm going to shade to the left. Some of you might like doing the shading part above, and that's fine as long as your teacher can clearly see which way we're shading. Alright, now let's do some slightly more difficult ones. Earlier in the video, I mentioned that solving an inequality is almost identical to solving an equation, except for one rule, and that's this new rule right here. Alright, when solving an inequality, the one thing that's different is if you ever, in the problem, have to multiply or divide by a negative number, we're going to flip the inequality sign. Inequality. So if it starts as less than and I multiply or divide by a negative number, I'm going to change it to greater than. So let's see how that would work. For 5 and 6, we're going to solve the inequalities. Again, just like solving an equation, but we have to pay attention to this negative rule. And then I'm going to graph the solution on a number line. So for number 5, I have 7 minus n is less than or equal to 19. Normally when we're solving, we'll get rid of these constant numbers first. So like in this case, that's the 7. That's a positive 7. So to get rid of it, I have to subtract 7. So both sides. 7 minus 7 is 0, so I'm just left with negative n, less than or equal to, and then 19 minus 7 is 12. Now remember, when there's a negative in front, that's like saying there's a negative 1 there. So anytime there's a number, we do have to get rid of it, and since this is like negative 1 times n, I'm going to divide by negative 1 to get rid of it. But wait, what was our new rule again? Alright, let's not forget it. It says if you multiply or divide by a negative number, we have to flip the inequality sign. So what I like to do when I notice it's happening is I write a little note to myself. Hey, flip. That way I won't forget, hopefully. Alright, so negative 1 divided by negative 1, that's gone. It's just n now. I'm going to flip my inequality sign, so instead of less than or equal to, it's now going to say greater than or equal to. And then you can use your calculator if you need to, or maybe you know 12 divided by negative 1 is negative 12. So there's my set of answers. Any number that's greater than or equal to negative 12 is a solution. So all that's left here is to graph it. So I'm going to draw my number line, plot negative 12. Alright, to the left, that's negative 13, negative 14. To the right, negative 11, negative 10. Is this going to be an open or a closed circle? Take a second. Think about it for a little bit. Got it? Well, hopefully you said, well, there's an equal sign here. So that means it's going to be a closed circle. Okay, and it's greater, because we flipped the sign, so greater than. That means I'm going to shade to the right. Put my arrow on the end, and there you have it. Alright, let's try one more. Number 6. So for number 6, again, we're going to solve it very similar to how we solve equations. When I have parentheses in an equation, I'm going to distribute so that there are no more parentheses. So 4 times 3 is 12, and 4 times negative x is negative 4x. And then I'll fill in the rest here. Alright, the other thing I do with equations when I have x's on both sides is I move them to one side. Alright, with inequalities, I highly recommend keeping x on the left side. I think it makes it easier to read it. So instead of moving the 5x over to the right side, I want to keep x's on the left side. So I'm going to move the 4x to the left. And since it's negative, I'm going to add. Okay. Anytime you're working with inequalities, just try to pay attention to whether you're whether you're multiplying or dividing by a negative. There, I was just adding, so I know I don't have to worry about it. Alright, let's separate these a little better. There we go. So now x's are on one side. I can just start solving like a normal equation. Alright, I'm going to get rid of this positive 3 by subtracting it. 9x is greater than 12 minus 3, that's 9. And then I'm going to divide by 9. Now, am I dividing by a negative number? No, 9's positive, so I don't have to flip the sign at all. All I have to do is say, what's 9 divided by 9? I know that's 1, so x is greater than 1. And then to graph it, again, draw that number line, plot the number, plot a couple bigger, a couple smaller, just so we have an idea where on the number line you are. And then this is going to be an open circle. Greater than is to the right. Boom, there it is. Done. Alright, so inequalities aren't so bad as long as you remember this new rule. So if you think that's something you need to write down on your homework to make sure you remember it, do it. Anything that's going to help you out, make those little notes, and hopefully you'll be all set. Alright, that's all for today. See you later.